Hey guys, so let's keep going and let's go to 12.2, and let me go ahead and open the PowerPoint. Okay, 12.2 follows 12.1, and now we're actually going to see how to make a line that best fits that scatter plot. So looking here, the least squared regression line is the line of the average variation for the data is the smallest. Also, it's called the line of best fit, and I actually think that's the best way to do it. So when you remember when you were algebra and you had the equation of a line equals y equals mx plus b? Yeah. So where m was your slope and b was your y-intercept. Well, right now we have one like that. We have y with a little caret on the top equals bo plus b1x. Sorry. And that b1 is the slope. This looks like no slope you've probably ever seen, because remember, when you're looking in algebra, the slope of a line is the change in y over the change in x. Well, a lot of different things are going on here. Basically what we're doing is we're having to find the average between the line and the points, and from there we decide, okay, with all these points on the line, this line is the best one to fit in there, to try to cross through as many points as all and make the variation least that it can be. Do you have to worry about figuring this out by hand? Oh no, the calculator does it for you. And here's your y-intercept. And again, what is the y-intercept? Even for a line of best fit or a regression line, it is where the line crosses the y-axis. Okay. So let's look at an example. A local school board wants to evaluate the relationship between class size and the performance on the state achievement test. It decides to collect the data from various schools in the district, and the data from the sample of 8 classes are shown in the following table. Each pair of data values represent the class size and the corresponding average score on the achievement test for one class. Okay, so let's look at it. Okay, we're going to determine if there's a significant linear relationship between class size and average test score at the 0.05 level of significance. And if the relationship is significant, we're going to make the regression line. So in your calculator, let's go ahead and put that back in like we did last time. So go ahead and get out your calculator, and if you need to pause the video, that's fine. So go ahead and turn it on, and remember to stat, enter, and L1 is going to be your X values. So that's going to be class size. So go ahead and put that into L1, 15, 17, 18, 20, 21, 24, 26, 29. And then in L2, you're going to put your average test scores, 85.2, 86.2, 85, 82.7, 81.9, 78.8, 75.3, and 72.1. All right, so go ahead and put those in. And then remember, what we want to do is we want to hit enter, we want to do stat, calc, and go down to number 4, and then hit enter. So you should be getting all this on your readout. A y equals ax plus b, then you get an a, and a b, and an r squared, and an r. If you do not get all that, then do this. Go to second, 0, scroll down to where you see diagnostic on. You see diagnostic on, hit enter, and then hit enter again. All right, so let's look and see what this is telling us. So A is our slope. So the slope for this line is negative 1.0434. B is our y-intercept, 103.085. R squared tells us the amount of variation between test scores and class size, and R tells us what kind of relationship we have. So let's break it down one by one. Okay, so when we look at the critical level of 0.05 level of significance, we go back to the back table in the book and we look and we get 0.070 because we need to figure out our N and our level of significance. We did this in 12.1. And then we're going to take the absolute value of R, because it was a negative, now we make it a positive. So we can say that 0.978 is definitely greater than 0.707. So there's enough evidence to say that there's a significant relationship. So then what we can do is we can go ahead and plug in our A and our B. So as you can see here, A goes with the X and B is the Y-intercept. So this is our line of best fit. And there's a lot we can do with it. And if you look here, we've graphed it. So that's the line of best fit. And if you look, it almost is including every dot. They're not always going to be this nice, but this is a really pretty regression line. Okay? And in the next video, we'll talk about making predictions with it. Thanks.